Hey everyone, welcome to our poster on self-supervised saliency detection titled 3SD Self-Supervised Saliency Detection with No Labels. This is a joint work with my advisor Professor Vishal and with the AIB team during my internship. Current deep learning based saliency object detection methods can be grouped into three categories. Fully supervised methods. These methods require input image and corresponding ground truth labels to train the network weights and perform the saliency object detection task. But to annotate the ground truth labels, it requires humongous human resources and time. On the other hand, weakly supervised methods requires weak labels such as classes, captions, or scribble annotations. But these weak labels also requires humongous uh, human resources and time to get these weak labels. On the other hand, unsupervised methods use handcrafted features to generate the pseudo labels and update the network weights to perform the saliency object detection task. But these handcrafted features might not be robust enough to the noises and might hinder the performance of saliency object detection task. To address these hurdles, we introduce a surrogate classification task to our 3SD method and generate cues from this self-supervised classification network and use these cues to generate pseudo labels to train our saliency object detection network. The following figure shows an overview of our proposed method where we can see classification task is trained in a self-supervised manner, and we use this classification task to compute the class activation maps and further used to generate the pseudo labels to train the saliency object detection task. To train the classification task in a self-supervised manner, we follow the well-known student-teacher technique introduced by Karen et al. But training the classification task using a single global class label might not give good quality class activation maps. Thus, we train the classification task with patch-wise labels using our proposed laws in the next slide. To improve the quality of class activation maps, we perform patch-wise supervision for the class labels using the contrastive based laws as shown here. Once we train the self-supervised classification task, we use the classification network to generate the class activation maps as shown here. Using the input image, we compute the edge map as shown here. We get the edge map using the class activation map to get the edges of the salient object as shown here. We define the pseudo ground truth label as a combination of the gated edge and the class activation map. And we use this pseudo label to train the saliency object detection network. To compare our 3SD method with the state-of-the-art methods, we train all the modules in the proposed 3SD method from scratch using the training dataset DUTS dataset, which contains 10,553 training images, and we use the following 6 benchmark datasets to evaluate the performance of our 3SD method and the state-of-the-art saliency object detection methods. We use the following 5 metrics to compare our method against the state-of-the-art methods. The following table shows the quantitative comparisons of our proposed 3SD method with the state-of-the-art fully supervised, weakly supervised, and unsupervised saliency object detection methods on the 5 benchmark datasets as shown here. Here we can clearly see our proposed 3SD method outperforms unsupervised and weakly supervised methods, and our numbers are on par with the fully supervised methods. The following figure shows the qualitative comparisons of our proposed 3SD method with the state-of-the-art uh, weakly supervised and unsupervised methods and fully supervised methods, where we can clearly see weakly supervised and unsupervised methods were not able to capture the finer details of the salient object as shown here. It misses legs and beak and legs of the horse in the second row. On the other hand, our proposed method produces clear and sharper salient object masks as shown here. It produces a sharper legs for these horses in the second row and a sharp beak and legs for the bird in the third row. The following figure shows the precision recall curve comparison of our proposed 3SD method with the fully supervised and weakly supervised and unsupervised methods, where fully supervised methods are indicated with the thick lines. Weakly supervised and unsupervised methods are indicated with the dotted lines. Here we can clearly see our 3SD method is on par with the fully supervised methods, where SOTA, a weakly supervised and unsupervised methods are far below in the graph. Following figure shows the evaluation study of our proposed 3SD method, where when we train the baseline network with edge maps as pseudo-ground truth, we obtain a F1 score of 0.75. On the other hand, when we use the class activation map as the pseudo-ground truth, we obtain a F1 score of 0.85. When we combine the class activation map with the gated edge, we obtain a F1 score of 0.87. Finally, when we use the proposed patch-based contrastive loss, we obtain the F1 score of 0.9. Thank you for attending our poster presentation. Code can be accessed using the following QR code.